In this example here, we have R2 and R3 announcing two networks into the RIP domain. Our objective is to restrict R2 from announcing its network to R3 and vice versa. At the same time, we need to keep announcing 192.168.1.1 to R2 and R3. We can do that using distribute list. Using distribute list, we can announce or prevent any routes out to specific interfaces on R1. To do that, we need to take two steps. The first is to create access list to deny the required network. The second is to match this access list in a distribute list out of the interfaces. Now we need to prevent R2 and R3 from learning each other advertised routes. We can do that using distribute list. Now let's check the route table for R2 and R3. Here in R2 we can see it's learning the network 192.168.3.0 coming from R3, and on R3 here we can see that it's learning 192.168.2.0 coming from R2. It's 32-bit network, so anyway it's 2.2. We can do that using two steps. The first is to define two access lists to match the advertised routes. The second is to apply two distribute lists to apply the access lists that we have just defined. So the first thing is to define an access list matching the route advertised by R2. Let's do that first. Access. And we need to add an allow rule to permit any other network advertised from R1, because the requirement here is to keep the network 192.168.1.0 for on R1 advertised to the two routers. So we need to add a permit any. Now we need to define the access route that matches router 3 network, and the same we need to add permit any to allow the network from R1. So as we can see here, those two rules will deny the network 192.168.2.0 and permit any other network. Now let's go under the RIP process. Sorry. Distribute. Distribute list. Yes. Then we need to match access list to out. So this is access list 2. It should deny network 192.168.2.0. We need to filter that out from leaving interface fast Ethernet. It should be 0/ let me review that. Should be fast Ethernet 0/1. And the same, we need to filter distribute list to apply access list 3 to filter the second access list from leaving fast Ethernet 0/0. So now we have the two distribute list applied. Now let's have a look at R2 and R3 route table. Okay, we can see here on R2 we have R3. Now it started to expire. If you notice here, it didn't receive any update regarding this route because R1 just suppressed the network 192.168.3.3 update using the distribute list, but it will keep it for 240 seconds, which is the flush timer. Let's check the flush timer on that route. Show IP photo. So it will keep the route here for the unflushed after. It will be flushed after 240, and it will stop sending any traffic to that route after 180 seconds. So let's keep monitoring that. As you see here, it didn't receive any updates, unlike the other routes. Let's have a look at R3, if we see the same situation there. Yes, we can see here it's already flushed out. Okay, after we complete the 3 minutes here, we should see this route as flushed out. Yeah, the flush timer here is 120. That's why it's already flushed. Let's run. Debug for IP rep R1. Check the route table for R2. Okay, it detected now the flush timer has expired, and it detected that the route may be down. So it should be removed in a while from the route table.